So in this case, we want to look at the basic mechanisms of soil and rock slope failure. So we want to have a look at these mechanisms that occur. So the soil and rock slope generally fail along the geological defect which we have established. It is only in a high slope or a weak rock that failure in intact rock becomes significant. So it's saying only in high slopes. So in high slopes here, we are referring to a situation where you think that, oh, my material is strong. I have a very competent rock. So instead of at least making your slopes to be quite gentle, you decided to put all your trust in your rock. And so your slopes are standing upright, 90 degrees. So when they are too high like that, then you are going to have some failure, slope failure occurring. Otherwise, you don't have issues. So it says that it is only in very high slopes or weak rocks. That is the situation where you can expect to have some significant failure in an intact rock, which we established that an intact rock is any material or rock material that is devoid of discontinuities. So most soil and rock slope problems therefore require consideration of geometrical relationships between discontinuity planes, the slope, and then the force vectors involved. So we are looking at these geometrical planes. At what angle or what phase is the failure occurring? These things are things we need to know and understand. And so as we forge ahead, we will come across the various types of failures in slopes briefly. So in weathered or highly jointed rock masses, the failure plane may be less controlled by single through-going discontinuities. And then analytical procedures for such slopes tend to be similar to those of soil. So if I have a rock that is highly broken, the behavior in terms of the failure is similar to that of soil, because if you are a rock and you are highly shattered, broken into pieces, forming a rock mass there, you are similar to soil. Then the common or the most important requirement of rock slopes is to determine the correct failure mechanism. Because if you understand the type of failure mechanism that is occurring, is when you can make room to anticipate them and some safety measures you can put in place to avoid them. This will generally demand a specific site investigation to evaluate the geology of the slope, the properties, and the characteristics of the discontinuities and the groundwater conditions. So these are things we need to carefully understand before the various steps we need to undertake in order to be able to characterize very well these failure mechanisms and then to make way for the remedies. So then let's see. The word stress has shown its face again. The last time I said that our rock has got to deal with the stress, the strain, and the strength. What is the stress? The stress is the load and the forces that the rock is facing. The strain is about the deformation that is going to occur within the rock when you apply the stresses. And the strength is the resistive force or the amount of energy the rock has got before it fully collapses. So now, if we are talking about stresses, everybody already has got some internal and inherent stresses within you. Without any other external force applied to you, you have your own burden. Nobody has asked you for school fees, but already within you, you also have your financial problems you are thinking about. That is your body force. So stresses are divided into two, the body force and then the surface force. So the body one is the one within you. without any other external forces, they are with you. And then the surface ones are the external ones that are coming to join hands with the body ones to torment your life. And so the term stress then takes the same definition, force per unit area. In other words, somebody will say it's like pressure. So the rock specimen having geological discontinuities such as the joint, when under the loading system, causes some kind of what? Sliding along a discontinuity. So the shear stress required causing sliding increases with increase of normal stress. So if a shear stress is going to occur to cause any, so the shear stress is now, let's say for example, these things you see there, if there's going to be any sliding force along any of the surfaces, you realize I have these colors, several colors. So let's say the failure is supposed to occur along this. There is that type of a normal shear stress that will be occurring vertically on top of the body, and others that will be occurring along the failure plane, tangential to it. So whilst one is pushing the substance this way to cause the sliding to occur, there will be some kind of a normal force that is also supplementing this process to occur more further. And so we are saying the shear stress required causing sliding will increase when the force that is being applied is also increased. And then the slope of the line relating to the normal stress and the shear stress defines the angle of friction. We have talked about that earlier. So the internal angle of friction is the one that is occurring as a result of the intact or the connection between two surfaces. Okay, so if the discontinuity surface is cemented or it is rough, so cemented here is talking about if it is such that it is rough, then sliding will be minimal. And that is why we don't want water to be present, because if water is present, it will render the friction useless, and then sliding is easier. So the initial value of shear strength defines the cohesive strength, our previous lessons. Then we have the relation between the shear stress and the calculation of the normal stress is now shown below. So let's take a look at this. So I have my rock material. The internal angle of friction, we said, is the friction that is existing between two surfaces in the material we are considering. And then the normal stress is plotted along this axis, which is what we used in obtaining our Mohr circles. And then this line here, the point here, from this point bottom, is what we term as the cohesion, which are the inherent properties existing within the material. So now, so the shear stress now is the sliding force that is being applied. And then there is that kind of a force that is acting vertically on top of the material. So the shear stress is the sliding force that is to cause the failure. And then the normal stress is a type of force that is sitting on top directly perpendicular to the body that is to experience the failure. Then we have another force, upward force, that is also preventing. So you remember when we did the uniaxial compressive strength test, our body was the schematic diagram was presented like this, because to every action there's an opposing reaction. And so once there is this normal stress coming down, there will be an opposing force to oppose that force coming down. And then the shear stress will also have its opposing force. And so a situation where the one that is opposing the stress is higher, will there be failure? No, unless this is greater, then the failure can occur.